and other Blue Water offices.
Out here, we are not only a freight forwarder, we are a very dedicated project freight forwarder that likes to handle complicated stuff. We did the groundwork for this project approximately 2 years ago, and we did a lot of studies back and forth, not only on a commercial level but also on an engineering level, because the cargo specifications are obviously very complex, and we have to be very thorough and have to provide our client with proper solutions.
The debut of the project brings us to Batangas, Philippines. It's here where today the future oil rig's massive pontoons will be loaded. Blue Water Shipping is responsible for the complete wet towage from the yard onto the semi-submersible vessel and the delivery of the pontoons to Singapore. Carefully, the tugs maneuver the steel colossus above the deck of the Casco XRK. Once in place, the water is blasted out of the ship's 61 ballast tanks, and both pontoons rest safely on the dry floor. The ship now sets sail to Singapore to deliver its expected cargo. The first stage of the project is successfully accomplished. The 2 pontoons will now be used to create the lower hull, the massive base structure that the future oil rig will be sitting on. 4 special tugs connect their pulling lines to the lower hull. The Blue Water team keeps a watchful eye on the operation. Slowly and precisely, the giant structure is maneuvered towards the Vanguard's deck. Meter by meter, inch by inch. Everything goes as planned. It's a major success. And finally, the lower hull is perfectly floated onto the Vanguard. Shortly after the Vanguard's departure from Singapore, the project's next phase commences: the lifting and transport of the oil rig's topside components. All heavyweight champions in their class that require complex engineering to ensure a smooth and safe delivery. Carefully, the large structures are lifted onto the vessel. It's a team effort and shows once more Blue Water Shipping's veteran experience in applying tailor-made logistics to the oil and gas industry. Precisely, in record time, with 0 incidents, and to the customer's fullest satisfaction. Finally, Hercules places the derrick tower accurately on its pre-calculated position. The ship has to travel 8,800 miles through the Indian Ocean, rounding the Cape of Good Hope, and then crossing the vast Atlantic Ocean to finally reach Angra dos Reis, where just now, the Dockwise Vanguard is about to complete her journey. On her way, she had to deviate away from 2 tropical storms and battle unfavorable currents. But now, she's here. It's a magic light welcoming a mighty ship. The pilot gets on board to navigate the Vanguard to her float-off position. Only an hour later, the gigantic lower hull structure floats off the deck. Delivered on time and without a scratch, it's a major milestone in accomplishing the project. Shortly after the delivery of the lower hull, the pilot station at Angra dos Reis receives a call from Combi Dock 3. Her captain reports she's on her final approach and ready to enter the bay. With 14 knots, she almost glides the remaining miles to the yard.
The motto is together we create solutions. It means that together with the clients and also the subcontractors, we sit down, we understand that our clients' difficulties, the challenges that they have to meet all their requirements in to deliver the project or deliver the cargo in a safe way and deliver on time.
By creating solutions together, Blue Water Shipping has once more proven to be the right and trustful partner for even the most challenging logistic projects. No matter what size, no matter how complex, no matter where in the world, together we create solutions. Blue Water Shipping.
ABS is leading the way. On the forefront of marine and offshore innovation for more than 150 years, we are tackling the most pressing technical, operational, and regulatory challenges in the industry, setting standards for safety and excellence as one of the world's leading maritime classification societies. Our mission is to promote the security of life and property and preserve the natural environment. At the heart of our mission is safety. What we do matters to the lives of people and the quality of the environment around the world. We're leading the way in the development of new safety standards, incorporating the latest technologies and risk-based approaches to periodic inspections. Our business is establishing and maintaining technical and safety standards throughout the life of marine vessels and offshore structures. ABS has a global team of surveyors, engineers, researchers, and regulatory specialists who provide a broad range of classification services, plus insight into new and emerging technical services designed to improve energy efficiency, environmental compliance, and life cycle management. ABS is a leader in innovation. We are a trusted partner with shipyards, owners, operators, designers, drilling contractors, and engineering companies. We collaborate globally with universities. Our focus always lies towards the future, and we work tirelessly to create game-changing technology and to develop modern design standards. We are developing and using the most advanced technology to address the industry's top technical challenges, from cybersecurity, big data analytics, autonomous inspection technology, crew safety, and the application of analytical tools. From Houston to Shanghai, Athens to Rio, and London to Singapore, ABS is guiding advancements in the marine and offshore industries. We are passionate about making the world a safer place and promoting practical and innovative solutions. We continue to lead the way.
We are Fluor. Building is our passion. It's in our DNA. It's what drives us to accept the most challenging assignments in the world. To work in some of the most inhospitable places on the planet. It's what we do. And together, we deliver an integrated solutions approach to our clients. It's the projects we execute. It's who we are.
We are Fluor.
We are Fluor.
We are Fluor.
我们是Fluor.
We are Fluor.
Somos Fluor.
McDermott is a company powered by people who share an enduring vision and uncompromising values. Working closely with our customers, we design smart solutions for offshore field development to help bring oil and gas to market safely, responsibly, and economically. Through advanced technology and the highest standards of performance, we deliver project certainty. McDermott is executing some of the most complex and challenging projects in the offshore energy business. Our global footprint of regional presence seeks to address national content while improving the communities in which we live and work. We are the partner of choice. Our expertise, vision, and values differentiate us and drive us to deliver excellence on every project, every time. McDermott, the right people, assets, and technology to bring
era of integrated global market, supply chain system optimization is the key to increase company competitiveness. Now, we take a big stride forward with one-stop solution based on the worldwide global network and a cutting-edge system. The global SCM innovator, CJ Logistics. CJ, a global lifestyle company, leads the lifestyle of people all over the world. Food and food service, bio and pharma, logistics and retail, and entertainment and media. CJ Group creates the culture of cosmopolitan people in 4 major areas.
ABS is leading the way. On the forefront of marine and offshore innovation for more than 150 years, we are tackling the most pressing technical, operational, and regulatory challenges in the industry, setting standards for safety and excellence as one of the world's leading maritime classification societies. Our mission is to promote the security of life and property and preserve the natural environment. At the heart of our mission is safety. What we do matters to the lives of people and the quality of the environment around the world. We're leading the way in the development of new safety standards, incorporating the latest technologies and risk-based approaches to periodic inspections. Our business is establishing and maintaining technical and safety standards throughout the life of marine vessels and offshore structures. ABS has a global team of surveyors, engineers, researchers, and regulatory specialists who provide a broad range of classification services, plus insight into new and emerging technical services designed to improve energy efficiency, environmental compliance, and life cycle management. ABS is a leader in innovation. We are a trusted partner with shipyards, owners, operators, designers, drilling contractors, and engineering companies. We collaborate globally with world-renowned universities. Our focus always lies towards the future, and we work tirelessly to create game-changing technology and to develop modern design standards. We are developing and using the most advanced technology to address the industry's top technical challenges, from cybersecurity, big data analytics, autonomous inspection technology, crew safety, and the application of analytical tools. From Houston to Shanghai, Athens to Rio, and London to Singapore, ABS is guiding advancements in the marine and offshore industries. We are passionate about making the world a safer place and promoting practical and innovative solutions. We continue to lead the way.
Is our passion. It's in our DNA. It's what drives us to accept the most challenging assignments in the world. To work in some of the most inhospitable places on the planet. It's what we do. And together, we deliver an integrated solutions approach to our clients. It's the projects we execute. It's who we are.
We are Fluor.
We are Fluor.
We are Fluor.
我们是 Fluor.
We are Fluor.
Somos Fluor.
McDermott is a company powered by people who share an enduring vision and uncompromising values. Working closely with our customers, we design smart solutions for offshore field development to help bring oil and gas to market safely, responsibly, and economically. Through advanced technology and the highest standards of performance, we deliver project certainty. McDermott is executing some of the most complex and challenging projects in the offshore energy business. Our global footprint of regional presence seeks to address national content while improving the communities in which we live and work. We are the partner of choice. Our expertise, vision, and values differentiate us and drive us to deliver excellence on every project, every time. McDermott, the right people, assets, and technology to bring project concepts to reality.
Technomac, an integrated engineering, fabrication and erection company, is geared to serve the growing needs of onshore and offshore oil and gas, marine, metals, power and infrastructure industries in the Middle East, Africa, Europe, the Far East and the Indian subcontinent. From a humble start in 2004 with 150 square feet office space and 6 employees on payroll, Technomac has grown to 1,500 plus employees. State-of-the-art manufacturing facility to meet industrial requirements like piping, pressure vessels, tankages, structural components, skids, modules, electrical and instrumentation and equipment erection. As part of commitment towards continuous improvement, Technomac has implemented integrated quality and HSE management system in compliance with ISO 9001, ISO 14001 and OSAS 18001, in addition to API 2B, ASME, U, PP and R certifications and British Safety Council membership. To provide the utmost care and best services to customers, the operations are divided into 6 business units: onshore and offshore oil and gas projects, mechanical EPC projects, skids and pressure vessels, shutdown and maintenance, shipbuilding, ship repair and conversions, offshore and marine consultancy. Technomac has its strong presence in the UAE, Qatar, India and Saudi Arabia, with its headquarters strategically located in Hamria Free Zone, Sharjah. Technomac's quayside yard, with loadout facility, enables heavy fabrication and transportation of large onshore and offshore structures and modules to various parts of the globe. For the execution of time-bound projects, Technomac has well-equipped facilities with overhead cranes, its own fleet of mobile cranes, forklifts, CNC machines, fabrication machinery, blasting and painting booths with recovery system, workshops capable of handling carbon steel, stainless steel and high-grade materials like duplex, super duplex, copper nickel and titanium. Technomac has proven its expertise in offshore oil and gas fabrication on various projects of Saudi Aramco, ADNOC, ONGC, Reliance, Qatar Gas, South Oil Iraq, Turkmen Gas, Maersk Oil Qatar, ENI, Dragon Oil and KJO, which resulted in partnering with many multinational contractors like J. Ray McDermott, Weatherford, Bumi Armada, Leighton Offshore, Petrofac, Swiber Offshore and Saipem. One of the first major projects executed by Technomac successfully was the architectural steel fabrication and erection works of Dubai International Airport Terminal 3, with a record of 0 accidents throughout the project span of 21 months. Technomac has executed projects in Emirates Aluminium, Emal, Dubai Aluminium, Hindalco, Qatarlum, Rio Tinto, Alcan, Kitimat Smelter, Canada, Sphinx Titanium, Jazan, involving modular construction and loadout of green anode paste plant, anode rodding shop, gas treatment centres and fume treatment centres for technology partners like Alstom, ECL, Fives Solios, Autotech and EPCMs like Bechtel and SNC Lavalin. These projects were delivered successfully with the highest level of customer satisfaction, which led to receipt of repeat orders. Tecnomac's contribution in the field of power, desalination and water treatment solutions are evident in the projects executed for Degremont Technologies, Entropy, Alstom, Mackie Boilers, Thermochemica, Bilfinger Babcock and Clyde Bergman. The projects include SWFGD, ESP, evaporators, stacks and diverters for heat recovery steam generator, deaerators, dampers and other associated systems for Marafik Yambu, NWC Saudi Arabia, CMI Energy Tunisia, Stalowa Wola Poland, Zwitina Project Libya and EGC Expansion Project Qatar. Tecnomac spread its wings to the Indian subcontinent, taking up the aluminium smelter projects of Hindalco, for which the company is involved in executing 21,000 metric tons of steel and equipment erection that includes gas treatment centres, fume treatment plant, storage tanks and piping. Tecnomac Marine and Offshore Consultancy, together with Offshore and Subsea Installation Division, gives complete solution to offshore field development and upgrades. Tecnomac takes care of end-to-end solution for feed studies and field development, load-out, float-off and transportation, pipe lay and flexible lay, installation engineering and project management, offshore T&I contract of topsides and jackets, subsea installations, brownfield and pipeline replacement, vessel upgrades, stability sea fastening, tow and mooring analysis, tender assistance and technical reviews. The division also specialises in impact and collision assessment, design of pressure vessels, project management, decommissioning studies. The project management and installation of cellar deck for Maersk Oil Qatar is a classic example of Tecnomac's expertise in offshore works. The scope of the work includes installation engineering, task risk assessment, load-out operation, trial lift and final offshore installation, which was completed with a high level of client satisfaction. Tecnomac's ship repair, shipbuilding and conversion division, with fully equipped repair workshop and machine shop in Dubai Maritime City, Hamria Free Zone Sharjah and Port of Fujairah, is engaged in dry docking, underwater hull repair, afloat repair, main engines overhauling, auxiliary and deck machinery refurbishment, hydroblasting, painting and electrical repairs of ships and rigs. The classic example of Tecnomac's expertise in handling unique projects is the conversion of a 100-metre flat-top barge into a floating knowledge enrichment centre developed from the concept to its completion and handing over to Doha Land Qatar Foundation, which involves design, fabrication, erection and interior works done in a record-breaking time of 85 days. Other significant projects include rebuilding of shear leg pipe lay barge Hyundai 423 with all new firing line and tensioners, new building of anchor handling tugs and diving support vessels. The company's endeavour to achieve excellence in project execution and operational efficiency has earned international recognition and acclaim in the form of various awards like Hamria Top 3 Award for Engineering Excellence in 2011 and 2012, Best Performance Safety Awards and various other appreciation from multinational customers. Tecnomac upholds the philosophy of delivering high-quality projects safely, on time and within budget to the utmost satisfaction of customers. This determination propels the company towards operational excellence through continuous improvement.
The Aries Group of companies was launched in 1998 with a vision of providing quality services to the maritime industry. The group, launched by Sohan Roy, a renowned naval architect with 2.5 decades of global experience, a multifaceted personality, now houses one of the largest engineering and inspection and oil and gas firms in the world. Our core activities are related to oil and gas, offshore, petrochemical and marine sectors. Built with the building blocks of innovative technology, customer trust and astute leadership, the company scaled the heights of growth to become a consortium of 43 companies, spread over 15 countries in just 18 years. The company, over the last 3 years, has successfully forayed into new territories like entertainment, cinema, 3D technology, healthcare and technical education, while consolidating our leadership in the maritime industry. The Aries team of over 1,400 engineers and professionals, having performed over 10,000 surveys, provides innovative technology solutions to cater to the wide-ranging needs of the maritime industry through its specialty divisions, including Naval Architecture and Engineering Solution 1, Offshore Engineering, Inspection and Maintenance, Ultrasonic Thickness Gauging, Non-Destructive Testing, OCTG, Load Test, Lifting Inspection, Third-Party Inspection Services, Plant Inspection, Rope Access, Marine Survey, Project Management, Yacht Interior, Marine Software and Technical Documentation, Electrical and Instrumentation, EIT, Advanced 3D Survey Technique, Corrosion Control Services, 3D Rendering with Interior Designing Services, Hull Integrity and Life Expectancy Survey, Risk-Based Inspection, Signage Survey, Valve Instrumentation, Calibration and Maintenance, Preventive Predictive Maintenance Survey, Mechanical Testing and Metallurgical Services, TPI and QA/QC Services, Scaffolding Services, Equipments and Trading, Blasting and Painting Services, ECDIS Commissioning, Visual Media, Software Solutions, Research and Training, and so on. Headquartered at Sharjah, Aries is a branch.
Fluor. Building is our passion. It's in our DNA. It's what drives us to accept the most challenging assignments in the world. To work in some of the most inhospitable places on the planet. It's what we do. And together, we deliver an integrated solutions approach to our clients. It's the projects we execute. It's who we are.
We are Fluor.
We are Fluor.
We are Fluor.
我们是 Fluor. We are Fluor.
Somos Fluor.
McDermott McDermott is a company powered by people who share an enduring vision and uncompromising values. Working closely with our customers, we design smart solutions for offshore field development to help bring oil and gas to market safely, responsibly, and economically. Through advanced technology and the highest standards of performance, we deliver project certainty. McDermott is executing some of the most complex and challenging projects in the offshore energy business. Our global footprint of regional presence seeks to address national content while improving the communities in which we live and work. We are the partner of choice. Our expertise, vision, and values differentiate us and drive us to deliver excellence on every project, every time. McDermott, the right people, assets, and technology to bring project concepts to reality.
Technomac, an integrated engineering, fabrication and erection company, is geared to serve the growing needs of onshore and offshore oil and gas, marine, metals, power and infrastructure industries in the Middle East, Africa, Europe, the Far East and the Indian subcontinent. From a humble start in 2004 with 150 square feet office space and 6 employees on payroll, Technomac has grown to 1,500 plus employees. State-of-the-art manufacturing facility to meet industrial requirements like piping, pressure vessels, tankages, structural components, skids, modules, electrical and instrumentation and equipment erection. As part of commitment towards continuous improvement, Technomac has implemented integrated quality and HSE management system in compliance with ISO 9001, ISO 14001 and OSAS 18001, in addition to API 2B, ASME, U, PP and R certifications and British Safety Council membership.
I'll be speaker 3, that's correct.
To provide the utmost care and best services to customers, the operations are divided into 6 business units: onshore and offshore oil and gas projects, mechanical EPC projects, skids and pressure vessels, shutdown and maintenance, shipbuilding, ship repair and conversions, offshore and marine consultancy. Technomac has its strong presence in the UAE, Qatar, India and Saudi Arabia, with its headquarters strategically located in Hamria Free Zone, Sharjah. Technomac's quayside yard, with loadout facility, enables heavy fabrication and transportation of large onshore and offshore structures and modules to various parts of the globe. For the execution of...
Ladies and gentlemen, can I have your attention please? And may I request everyone to take your seats please. Hope everyone is comfortable now. Thank you. Ladies and gentlemen, it is my great pleasure to welcome you all to 4th edition of MarsTech, which is MarsTech 2017. Before we move on, let me remind you of few checks which you need to do. One is actually safety. Safety is very important. So we have got 5 exits from this particular hole. So 2 on my left, 2 on my right, 3 on my left. And you have to follow the stairs up and behind where the car park is there. That is where the muster station is. No drills planned. So if it is an alarm, it is real. Restrooms are just right across to the left. And if anybody wants to fill their stomach, don't worry, food is available in the alleyway. We, the naval architects of Cochin University and Science and Technology, are proud because of the reception we got and the acceptance for Mastech 2017 from across the world. We have got people attending from Americas, Europe, Far East, Indian subcontinent, and wider Middle East. I'm sure that Mastech will be playing a crucial role in influencing the turnaround of the industry, which is at its low now. But in the near future, it will come back with a big boom. What you are going to experience today is hard work of very energetic young naval architects, including me. I'm not that young, but still. Young naval architects who put their extra efforts, including their day work, extended hours, and weekends to make this Mastech 2017 a reality. 1st August 2010, when I was reading the newspaper, The National, this particular headline hit me. Dry docks, ship shape for a launch. It was not because of that particular headline it struck me. It was because of one gentleman who was much more handsome than me. As you may notice, there are very few in this world like that. Yeah? He is the architect behind Dubai Maritime City. Who else is best suited to get our Mastech 2017 going other than somebody who is at the helm of the gateway for all the trade between marine, oil and gas, and even logistics world. Help me in inviting Mr. Hamad Al-Maghrabi, General Manager of Abu Dhabi Ports and Marine Services, to the stage. Mr. Jolly Kurian, can you? Thank you, sir. Thank you, Jolly. 1972 is a very important year. Not because I was born on that year, because one of the great professors graduated on that year. He went on to mold naval architects from Cochin University from 1983 to 1986. Later, he thought it was enough. He moved on to another industry, which is intellectual property. And Mr. Leske, Dr. Leske, is here, and he has flown all the way from Munich to attend his own students' organized Mastech 2017. Let us welcome him onto the podium. Mr. Changa. Okay. Mr. Jolly, can you? Thank you, Dr. Leske. Thanks, Changa. We also have been privileged by the presence of Mr. S.W. Kim, Vice President of CJ Logistics, who is actually one of the main sponsors of this event. Without him, we would have struggled to have this one a reality. So let us welcome Mr. S.W. Kim on the podium. Mr. Jolly, can you? Thank you, Mr. Kim. Thank you, Jolly. A man who showed his leadership skills and he implemented his project management skills to make this big project, Mastech 2017, a reality. He is none other than our own president, Mr. Jolly Kurian. We welcome Mr. Jolly onto the stage. A big personality who was the conduit for all the efforts of Mastech 2017 is our own convener. So, I welcome Mr. Shankar VG, Master Convener, to welcome you all. Mr. Shankar.
Thank you, Shane. Good morning, ladies and gentlemen. Respected Chief Guest, Hamad Al-Maghrabi, General Manager, Abu Dhabi Marine Services, Dr. Thomas Leske, Mr. S.W. Kim from CJ Logistics, he's the platinum sponsor of this program. Distinguished guests, our President Jolly Kurian, speakers, sponsors, Biztv Events, the organizer, friends, welcome to Mastech 2017. I am pleased to see so many delegate representations from around the world in one place. Mastech conference provides a very unique opportunity for all of us to meet colleagues from our own specialty area. The organizing committee of Mastech 2017 have worked extremely hard for the last year to prepare and conduct such an outstanding conference. An impressive roster of distinguished speakers from US, Korea, and UAE has been assembled for this opening ceremony and plenary sessions. We have successfully managed the whole conference with a comprehensive online process for abstract and paper submission, conference registration, and other services. General sponsorships from CJ Logistics, Blue Water, Fluor, Technomac, ABS, and McDermott have recognized that Mastech conference is an important venue to discuss topics related to shipping, offshore, and marine logistics. I am all the more delighted to welcome you all as the convener of Mastech 2017. With this, I will welcome our President, Jolly Kurian, to give the presidential address. Thanks.
Thank you, Shankar. Good morning, everyone. Honorable Chief Guest, Mr. Al-Maghrabi, respected Professor Dr. Leske, Mr. Kim from CL Logistics, who is our platinum sponsor, distinguished VIPs, guests, fellow Mastians. I'm extremely honored and elated at this moment to stand in front of you today. Mastech 2017 is becoming a reality. Proud moment for MAST, the Middle East alumni of ship technology, and its brainchild, Mastech. If you look at the history, we started Mastech in 2008 in Dubai, Crown Plaza. And then we went on to do the second and third editions in 2011 and 2013. Well, here we are. It's the fourth edition, and we are extremely proud to present Mastech in a bigger, face uplifted way. Well, meanwhile, we also thought we were missing something back in the campus. So we started doing Mastech back in Cochin University, the alma mater, with an objective to say that to bring the industry back to the campus, to bring the knowledge back to the campus and give it to them. Extremely huge success. We did 3 of them in Cochin. So that's total 7 Mastech. All I'm saying is Mastech has really maturing in its journey. And I really thank you for the entire maritime industry in the support and development of Mastech. Well, what are we doing different this time? Mastech is actually, we are taking Mastech to the next level. We are registering Mastech as a trademark in India and UAE. It's happening now. It's pretty much near to completion. By end of this month, we will be trademark registered in India and UAE. Then the next step is to take it to the other parts of naval architects, Singapore, UK, and probably US last. So that's where Mastech is heading. And today, you will see the Mastech being supported almost globally. You have Dr. Rahim sitting here, who is going to lead one of our major panels for today, who flew from London last night. You have Dr. Leske sitting here to address us as a keynote speech later. Flew from Germany last night, remembering us the relationship we have with Rostock University. So Mastech is really becoming global. I'm saying Mastech is set to go places. I really looking forward to your support, continue your support to mature this brand. Well, we also changed the format a little bit this time. We started working on Mastech probably 8 months ago, started looking at what are the real burning issues and challenges we should look at. And then when we start to realize that, yes, there are common issues coming from individual organizations. There are people working in different silos. We want to connect them together and use Mastech as a common platform. So our panel on big data and Internet of Things is a great example. We have Rolls-Royce working in certain regime. We have DNVGL working in a certain regime. We have Class NK working in different regime. We're saying, come together, and we'll have Dr. Rahim moderating. And I'm really looking forward to that session on how we interact, and probably extend that later to the oil and gas sector as well. I'm sure today, don't discount. It's a great opportunity for networking. We have all these participating companies and also the various companies around the world here, including their senior management. So use that opportunity. And I hope it will be a great day to share the innovations, share the ideas, healthy debate a little bit. We are happy to do that. So really looking forward to that opportunity. Well, I'm sure you will all remember OTC as one place we all go for networking. I would say Mastech has a much broader depth, because we are not only covering oil and gas, we are covering the naval architecture, we're covering the marine shipbuilding, rig building, the entire marine fraternity. So Mastech definitely have a broader approach to the entire thing, bringing the innovation, the thought ideas together. So I wish you all a great day, a successful event. Engage with your speakers, panelists. Let's get the best out of this. And as I said before, my message is, Mastech is in its way to become global. I request your support, continued support in that journey. With that note, let me take the honor to welcome Mr. Al-Maghribi to do the inaugural speech and declare the Mastech open. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, ladies and gentlemen. Welcome to United Arab Emirates and Dubai for the people who flew to UAE. I would like, first of all, to thank the organizers today for allowing me really to stand here in front of the esteemed group of talented and leaders into this industry. Today we're going to talk about the green technology solutions into the maritime environment. I think before we start this topic, which is divided into two areas, it is the technology in marine environment and what's how that being achieved, and the green technology and why is that affecting every day in our works. Before we get into this one, I think we need to acknowledge really the role of maritime and how does that add huge value to our economy. I think today 90% of the whole world economies or trades is being moved by sea, and that's really, it's a great achievement to the new technologies being applied into the maritime industry. Technology has played a big role, really, into this area, achieving the efficiencies and applying into the ports and maritime, as the ports areas, maritime tugs, ships, cranes. It's been really played a big role. Throughout the years, the pressure into the ports planning, as everybody knows, every port wants to be in the top of the role into this area, so everybody or each ports have applied the new technologies to ensure it's reached to the highest efficiencies. I think this one also introduced such as a new cranes, greater machines, equipment, tugs applied into each port to ensure that we are moving to the highest efficiency, lower environmental effect into the ports, into the areas around us. Some of the worldwide trends leading toward to the fitting to the. I mean, a lot of people thinking about that. Diesel engines or the environmental effect. Some areas maybe think is not the one is leading, but I think we're putting a lot of effort to that. Really, the new technologies and the green environments add huge value to our areas and increase our efficiencies. Sustainable green approach has always topped in UAE. In UAE here, we put a lot of efforts into the green environmental, into sustainable energies. As you see in the solar areas, you've noticed that a lot of people put a lot of efforts really into that side. Our leaders have spent a huge amount as a government amount of money, maybe nearly 250 billions to reach to that sustainable energies to be applied in UAE and allowing UAE to be as a leader into that side. In Abu Dhabi ports, strongly we commit to the green environmental communities, and we'd like to ensure, especially in Khalifa ports now, after we trying to transfer everything from Zayed ports to Khalifa, we're trying to put everything into the controlling the environment into that side, and we use the new technology. I think Khalifa ports become now a semi-automated area that's helping a lot in the timing and efficiency of the ports. That's, helping a lot of our support. At the same time, we are, as a marine side, the Safin, we're putting a lot of effort to go to the hybrid tugs, the new technologies into that side, and we invest into that side by really talking to the universities and colleges to get as much as we can from that, how we can reach to the new technologies and the best environmental effect into our ports. The new innovative solution that will help the industry to achieve the goal, sustainable development never stopped. Of course, that's as we know all. Moving to the fast piece, the challenges continue to grow on a faster rate. Of course, there's a lot of huge challenges, new things. The new technology is becoming fast. In the tugs, of course, in the acids, you buying the acids, it requires a huge time to replace this one. So the technology is putting a lot of effort on us and challenges. And today, events serve the purpose, as we say, the engineers, the naval arch engineers, I think they put a lot of efforts into building up into this one, and into the new assets or new technologies be applied into our assets. An IT solution, of course, is part of the technologies. I believe that we are gathered today as a maritime community have the power to achieve sustainable maritime environment. So I hope the outcome of this event today indeed will feed into the real and achievable plan to make a difference in our maritime community for a better life. Thank you really all, and I really appreciate your listening. Thank you. And this is where is?
Yeah, you have to. You can just say.
Okay, and really I announce today the opening of the Mastic.
Thank you, sir. With Mastech 2017 officially inaugurated, please note that if anybody wants to watch the live webcasting anywhere in the world, it is available in www.uaemastech.com live.php. If anybody wants to share this with your friends, it will be nice so that people can, in their convenience, can watch Mastech on their desktop. So next, I invite our own Dr. Leske to deliver his experiences with Cochin University, as well as with his new venture in his new career. Let us put our hands together to welcome Dr. Leslie.
Thank you very much for the cordial welcome. I also would like to extend a warm and cordial welcome to every one of you, to all the participants and guests, to all the specialists, to the speakers of MassTech, to all business people who have come to renew old existing relationships, and to those who would like to establish new relationships, which is MassTech also for. And last but not least, I would like to especially extend a cordial and warm welcome to all of my former students from Cochin University Department of Ship Technology, the organizers of MassTech. I feel deeply honored to have been asked by them to come over here from Germany and to just say a few words as a keynote speaker, including some personal experience I had when I was teaching them. This is has been a very, and still has been a very close personal relationship to Cochin University and Department of Ship Technology in particular. All my former students, I had the privilege of teaching them, had been the most diligently working, the hardest working, and the best students I ever had. This is something I would like to say in the very beginning, because it has been a wonderful time to teach them, and I still remember very often those days. And in between, I've visited the department many times. Of course, I did not meet my older former students, but I met new ones, and I do hope that they also will work as hard and as diligently working as the students I had the privilege to teach. That was in the years between 83 and 86, already mentioned. The teaching took place in a scheme of classrooms with 20 students we took in every year. When you teach just 20 students for quite some time, you get to know them personally, and this relationship extends beyond the simple teacher-student relationship to a personal one. And this personal relationship is still there. When I arrived yesterday, it was such a warm welcome for me. I didn't expect this, and I feel overwhelmed. When building a house, you usually start with the basement. As far as the personal career of everyone is concerned, our basement is knowledge. The knowledge it is our obligation of the older ones to pass over the knowledge to the next generation. And it is also such events like the MassTech conference to exchange knowledge, to develop knowledge, and to share knowledge with all the experts in order to bring forward, in order to develop the new technology for making our life better. Another very important aspect of our days is internet. Internet brings people closer together than ever. So to say, world becomes a village. And this was true in particular when my students tried to contact me again, because, as already mentioned, in 1992 I left teaching business and I joined a completely new area, the IP world, intellectual property. Subsequently became a patent attorney, European one, and a German patent attorney. And I, so to say, lost track at least a little bit to marine engineering and ship technology. It was quite easy for my students, as they told me, just to hit the button and get into contact with me. This is what is quite important these days, that we are closer together and it's much easier to share common knowledge as the basis for any further development. I don't want to speak much about IP, but knowing that quite a few business people are among us here, they know that IP is a business tool, one of others. It's a very important one in the sense that IP helps protecting new ideas, and a conference like this is also to develop and to exchange knowledge and experience about new ideas. And IP is also important for protecting new ideas. In these days, more and more money will have to be spent for creating new things, for developing new things. And the more money you spend, the more important it is to get it protected in order to prevent others from simply copying it without spending that much money. And that is what I do in my world now. So at the first glance, it may not be too much relationship with the technical issues to be discussed here and the IP world. But at a second glance, you realize that all these things belong together to successfully make business. And that's what we are here for. When I was asked by my former students as to whether I will come down here, I readily agreed. When I also was asked to deliver a paper, I had to decline because I would like to leave delivering a paper to those specialists and experts who've been working all the years in that field, which I didn't. But I will be eagerly listening to the new developments and to refresh my knowledge in that field. When I mentioned the internet that will bring people closer together, this includes an issue that will also be part of our panel discussion, the big data. There's a lot of controversy currently going on, in particular in Europe, in America, and in other parts of the world regarding collecting data. Collecting data is, by quite a few people, considered to be a danger. My personal view on this is we should not be afraid of this, because collecting data, once we have established rules how to deal with this data, we can create new jobs, we can create new developments, and we can bring forward technology in any kind of technological field. To that extent, it's more a chance and a challenge than a danger. And I wonder what the discussion, the panel discussion with the big data here will bring out new ideas. I'm eagerly waiting for this discussion. As already mentioned, we will listen to papers today in simulation, calculation, future design of shipyards, and we will have the panel discussions, big data, the panel discussions, sustainable energy, which is also a very important one, and it's quite interesting for me to learn that this is an issue on a conference like this one, the MASTEC, because sustainable energy is anything that can only be globally solved for mankind and is getting more and more importance. I wish this conference any possible success, and I wish all of us, including the organizers of MASTEC, many more MASTECs to come. Thanks for your attention.
Thank you, Dr. Leske, for sharing his experiences as well as his knowledge with us. Next, I would like to invite Mr. S.W. Kim to say a few words on behalf of CJ Logistics.
Good morning, everyone. Already introduced, my name is S.W. Kim. I'm the Vice President of the CJ Logistics. Firstly, most, I'd like to thank for you all for inviting me and our company in this forum. And fortune and giving to us and the opportunity to and speak to and this stage. Also, thanks for like to and especially thanks for Mr. Cyril Weiss for allowed us to have this sponsorship and with Mastech. Today, this probably and this many of you may not hear about our company name is CJ, but however, we are actually the original of the Samsung Group. Now we are expanding our business, M&A, and is going to become a global top 5 by 2020. And our logistics company, additionally, in this afternoon, we received the chance, the opportunity to introduce our company. Therefore, you can have a time to understanding us and wish to, and so we can provide to you. I would like to say that the two words, information and communication, are often used and interchangeable, but they are signify quite different things. Information is giving out, communication is getting through. We all know and without a strongly relationship with others, it is impossible to have a successful business model. As a result, we are so happy to be here, and we would like to have a conversation with you as much as possible and during today. We are strongly and believe that today is the first of the day of our company to join this meeting in this forum, but from tomorrow, we will more interact with all of you and bring the mutual and benefit to all of you and communicatively and personally. Once again, it was my honor to speak in this front of you, and I would like to thank for all of the people who that has been done this and this fantastic work of the performance and the organization and the hosting of this forum. Thanks very much. Thank you.
Thank you, Mr. Kim, for your kind words and presence. Normally, when we invite somebody for an inauguration, it is expected that we give gift to that particular person. This time, Mr. Hamad Al-Maghrabi has been kind enough to give Mastech a gift. This is unusual, but let us receive it, and I will request Mr. Hamad to hand over it to Mr. Jolie. Thank you, sir, for the kind gesture and also your esteemed presence. I think I will invite our energetic MAST Secretary, Mr. Arjun, to give official word of thanks.
Good morning, everyone. It's been an amazing journey the past few months, planning and preparing for this, the 4th edition of Mastech in Dubai. And standing here, I'm proud to see the culmination of those efforts. I know that we have an amazing lineup of speakers, panelists, and moderators lined up to make a truly informative and productive session for all of you. And I would like to thank, on behalf of MUST, one and all who have made it possible for this MUSTEC 2017 to become a reality today. I would like to express our most sincere gratitude to the dignitaries on the dais, Mr. Hamad Al-Maghrabi, Dr. Thomas Leske, Mr. S.W. Kim. Your presence has really brought esteem towards this inauguration session. I would like to thank all our sponsors, in particular CJ Logistics, who are our platinum sponsors, our cocktail sponsors and our gold sponsors, Blue Water Shipping, our other gold sponsors, ABS, Fluor, McDermott and Technomac. I also express our thanks to all the associate sponsors and supporting organizations who have helped us in organizing this event here today. A big thanks to the speakers and moderators, the panelists who will be coming on stage here today. You are the heart and soul of this event, really, and our advisory committee has handpicked you because we think that you are the best in the industry to bring out the best views, the best ideas for the topics that are brought up for discussion today. So big round of applause for the speakers and delegates. I thank all the delegates who are present here today. It was especially heartening to know that we have delegates from 4 continents here today, so that's very good to know. And if all our plans work out well, I think that pretty soon you'll have a MUSTEC event in a city close to you. So let's hope for that as well. Thank you to all the delegates who are here today. Last but not least, I thank our hosts here today, Dusitani, and our event managers, Aries Biztv Events, for creating this ambience here today. And I'm sure we'll be thankful for you. We are thankful for you for the productive session that we'll be having ahead of us. Thank you once again to one and all who have made this event a possibility. And thank you. Over to you, Shine.
With this, it brings an end to our inaugural session. So I'll request all the chief guests to return to their seats. Thank you. Thank you, sir. Thank you. Without any delays, we will move on to the next session, which is actually a paper presentation. And to lead the proceedings, lead from the front, our president will do the honors. Mr. Jolly Kurian to take us through the next session.
All right, I'm excited. MUSTEC is inaugurated. All right, okay, what to expect today? We have, in short, 2 individual papers and 3 panels. As I said before, panel is nothing but, a mix of, a theme is created and discussed between the various organizations, and then we moderate between them. So it's not discussion alone. Each panelist will be presenting a paper of maybe 10-15 minutes, and then we'll have the engagement with the audience. So in short, 2 papers, 2 individual papers, 3 panels, then we are done. All right? Okay, then we go into the award ceremony. That's about 5:30. Then we have a categories, about 8 categories of awards we'll be presenting to the various organizations. Then we are off to the poolside for a cocktail session. So that's what to expect today. All right, without much ado, let me go introduce the first paper for the session. McDermott has been the pioneer in float over technology. Floating over decks over jacket. McDermott is the pioneer on that technology. So today we have someone from McDermott to talk about float overs. Well, it's not about, how we do float overs. It's probably a bit more about what's new in float over. What would you change in jacket and topside designs to, what would you consider in float over design? So can we have a big round of applause for Saibal Paul? Saibal Paul is the principal naval architect from McDermott. Saibal has been in the industry for 28 years, graduated from IIT Kharagpur, and then you went on to do your master's in Kharagpur itself. So overall 28 years of experience. I think you have done all of it, right from ship design, construction, classification societies, installation of construction support engineering for McDermott. So 28 years of experience. Here you go for Saibal. Maybe I'll just ask you, is there anything you want to highlight from your career as part of your introduction?
Oh, thank you, Jolly, for this kind words. It's flattering. Well, I've done, as it says, we have done quite a few things in my 28 years. One of the biggest achievement or happiness that I've gotten was doing in fact, it was the second float over that was done in the Gulf of Mexico, in the Bay of Campeche. We missed being the first one because we were a little bit late in the delivery and somebody else overtook us and became the first. So it was an area, where, it's very prone to cyclones and things like that, and we had designed the float over in such a way to find out what is the right weather, limiting weather conditions and so on. It was a wonderful experience. Thank you.
So that was, okay, Gulf of Mexico is prone for hurricanes and it's one of the most complex locations for float over. Absolutely agree. Anyway, thank you. I know from your personal side, you've been a terrific badminton player.
Thank you.
All right.
And we had a lot of tough matches between he and I.
All right. Welcome, Saibal. Over to you.
Thank you. So I'll keep this mic back and do you have a pointer? Yeah. Okay, thank you. So let me start making my presentation. We will, first of all, let me thank Mastic for giving me the opportunity to come and speak here and giving me the opportunity to be the first speaker. So it's a bit like I'm a cricket enthusiast as well. I feel like being an opening batsman. You go out and you do your job and then you come back and enjoy the rest of the match in peace. So that's what will happen to me. I can sit back and relax and enjoy the rest of the speakers after I'm done. So in this presentation today, we will not talk about float over in a big way because the time is short. We'll focus in one particular area, which is the computer simulation of loads. How you calculate the loads through a computer simulation and find out how they play a role in determining the jacket doing the design of the jacket on the deck, and how that goes to decide whether the float over is a feasible option or not. So it's a very specific small area of float over. But I know this is a very acrostic audience kind of. The audience is very from various fields. So we will talk about a few things before we get into the real subject. So what I'm going to cover today is, first we'll talk about the basics of float over, hardware for float over engineering, because we need to know some of the terminology, some of the stuff that is used in the float over. So once we understand these two, then we talk about the computer simulation, how they are done. And finally, as the subject today talks about the drivers, how we decide for a float over or we don't. From there, so now getting into the business of float over, maybe most of you know what is float over, but still I would like to explain what it is. Float over, as the word suggests, it is floating over a deck on a pre-installed jacket. What does it mean? Okay, before that, let me also tell why float over. Before we were listening to what is float over, so we should know why do we need to do float over at all. So the reason is that first we are all building the jackets and decks on shore and then transporting it to the site and installing. So installation is often done by floating cranes, and so the lift capacity of the crane actually determines what you can install. What I mean is that if you have a deck which is 20,000 tons, there's possibly no floating crane in the world that can lift and put it in place. So you have to use some other technology. Either you kind of break down the deck into small modules and do it separately, or do something like a tandem lift, and these are the various ways of doing things. Or you can do something called a float over, where you don't have to, you can install the prefabricated deck in one shot without breaking down into modules. There's also another reason which is particularly pertinent in this part of the world. We are doing quite a few installation in shallower waters. Let's say you are doing a deck installation, 3,500 ton deck, which is not a very big deck, but the installation water depth is 5 meters. Now in that, it's impossible to bring a floating crane whose draft will be possibly more than that, and it will get grounded. So to do that, you can also use this float over as a technology. Okay, so essentially we do float over where we can reduce the hookup and installation cost, as well as in areas where others' way of doing installation is really not a possibility. Now I just show you a picture of one of the very big float over decks that McDermott has built in past. This is a 20,000 ton deck for the Sutuang down in Southeast Asia, in the Gulf of Thailand. So these are the sizes of deck that are being built and are being installed. Now, what is done in a float over? Now, well, here I would like to explain in the drawing. How do you operate the pointer? Okay, thank you. Sorry about that. So you can see here, this is the jacket which is pre-installed. And then this is the deck which is sitting on a barge. So the barge brings the deck and goes into the slot and installs. I mean, it's much easier. I can show you like this. Say this is the deck, this is the barge. The deck sits on the barge like this. This is the pre-installed jacket. So the jacket, the barge drives into the slot, takes in water, becomes heavier, transfer the load, and slips out. It's as simple as that. But it's really not as simple as that. There are much more than that. So what I explained through my hands and my phone is explained in the slides here. So what we have here is the first step where we have the pre-installed jacket here. And jacket is installed, piled, etc. There is a barge here which is carrying the deck. And you can see the part of the deck is protruding out of the jacket, of the barge for obvious reasons. So this is what we call as the approach or the standby. Then comes the second step, number 2, which is here. The barge slowly enters the slot and with a clearance, because as I said, the jacket is here, the barge is here. You shouldn't go in a way that you go and hit straight into. So you have to have a clearance, you have a higher draft, float in, and then take in water and slip out. So that's what is happening here, the step number 2. Then in the step number 3 is where the barge is into the slot, the weight transfer is happening, the barge is taking in water, becoming heavy, weight is being transferred from the barge to the jacket, and after this is done, the 4th step is the barge having slipped out and the installation completed. So these are the 4 stages of float over. Now, obviously, this kind of technology or this kind of installation cannot happen in very heavy weathers. It needs a decently calm weather, otherwise, the loads are too high. So typical weather for float over is like this. On the head sea, you have about 1 meter. On the beam sea, 0.5 meters. Winds about 10 meters, 10 knots, 20 knots. And tide, of course, you don't want too much of a tide difference, because in that case, you have to really have that much of clearance to go into the slot, and you have to take more water to sink, and it makes the float over slower. Now, for the equipment. Quickly going through the equipment that you need for the float over. The first is, of course, the transportation barge. Because, as I said, you have to build the deck in the shore, put it on the transportation barge, and take it to the location. So for that, you need anchor handling tugs. I mean, if it's not a drive-in vessel, it's not without propulsion, then you need anchor handling tugs as well. Then what is there? There are certain specific equipment that you need in the barge. Because as I said, when you go into the slot, you don't want this fellow to run away. So it has to be held back. So you need, like a naughty dog trying to run away, it has to be leashed. So you need the leashing, which is nothing but mooring. So it has to have mooring in place. And then I said, when you do the weight transfer, you have to take in water, make it heavier, go down and slip out. So that means you have to put in water. That means you need a ballast system. And a conventional ballast system on a barge may not work because you need tons of water. For example, if you're doing a 20,000 ton of deck float over, that means you have to take in 20,000 tons of water, because once the deck transfer has happened, the barge will try to pop back, and hit the deck. So 20,000 tons of water, if you're taking at the rate of 1,000 ton an hour, let's say it takes 20 hours, which is not a feasible solution at all. So you need very fast ballasting system. So that's something that you need on the barge. Okay, so that's what we talked about. This is something called a rapid ballast system or an external ballast system that we need which augments to the existing ballasting system on the barge. Then you need something called the shock cells, because again, when you go in, it's not calm sea. The thing is going up and down. So every time the deck is going up and down till the time it's meeting, it's just going bang, bang, bang. So whole lot of shock loads are being transmitted on the shock cells. That will have impact loads on the deck that might damage your deck or the equipment of the deck, or it may damage your jacket. So you need to have shock cells which will compensate and take care of this impact loads. So that's the shock cells. And also you need something which is between the jacket and the barge, because when you go into the slot, this can go sidewise and keep on hitting the jacket, sides, the walls of the jacket. So these are the various shock cells or shock absorbers that you need between the equipment. Now, remember we had talked about the four stages of float over. First one was standby, then was the entry, third one was the mating, where the actual load transfer happens, and the fourth one was exit. Exit. So of the mating stages, it's very important for us to understand the mating sequence, because that goes in a long way to explain the loads that we calculate, because the load transfer is essentially happening at the mating stage. So understanding mating stage is a little important. So let me take you through the mating sequence through a number of mating sequence drawings or sketches, and I'll explain to you what happens. So first, as I said, is the entry stage. So as you can see here, this is the jacket, the barge, and I'll come to these. These are the mating units. So this is called what we call as the mating deck leg mating unit, and this is the jacket leg mating unit. And when you enter, there has to be a physical clearance between the two, because when you enter, you're going through sea and there are motions. So if you do not have that adequate clearance there, you are likely to go bang into the jacket leg here and damage the jacket leg as well as this. So, but again, if you have too much clearance, just imagine that to be on the safe side, you had, let's say, 1.5 meter clearance. Then you must also remember that you have to come down by so many meters to do the mating happen. So that means you will need a lot of ballast, which will make it very slow system. Your float over will take a lot of time. So what you are looking at is ideally optimizing what is the gap that is required, so that you don't end up banging into the jacket leg when you are doing the entry, as well as it is not too much. So after that, I'm sorry, what happened? Yeah. So after that is the next step, what we call as the zero clearance stage. So what happens is let me again go back to my hands. So this is, let's say, the leg mating unit from the jacket, and this is from the deck. The deck has got a cone, which we call as the stabbing cone, which I'll explain a little bit later. And you entered with a clearance so that you don't go and hit straight away. Now you start to take water so that the barge starts to settle down. And the stabbing cone comes in line with the cone of the receptor cone here. So this one has a receptor cone here, and this one has a stabbing cone. So at this point, you are actually making sure that you are in the vicinity of the capture. You know what? Because if you have not aimed it properly, you may go somewhere else and you might end up doing the float over in the water instead of doing it on the jacket. So this is a very critical step where we stop and take stock of whether we are in line. Then comes the actual load transfer to happen. The first one is what we call as the zero load transfer. That means we now go in and we are just inside the cone, but the load transfer hasn't happened. We have just been completely captured. Now this is a very critical situation because this is the time the maximum lateral loads happen. Just imagine the barge is still free to move around and it's inside the cone, so there's a lot of heating that will happen sideways. So these are the situations where the X and Y loads are the maximum, and they go a long way to determine the jacket design. After that is what we call as the 100% load transfer, where we take in more water and slowly all the load that was on the jacket is now getting, on the deck is now getting, from the barge is now getting transferred on the jacket. And the shock cells are fully engaged and they are fully compressed. They're taking full load. And this is the time when the maximum vertical dynamic loads will happen, because it has already taken the maximum static load plus the sea waves are pushing the barge up and down. So it is going up and coming back with acceleration. So maximum vertical loads occur at this point of time. And finally, after you are done with the load transfer, you ballast the barge furthermore, create this clearance here. That means you have had more water. This faceplate between the deck lake mating unit and the what you call as the DSU. I'll come to all this terminology a little bit later. So this happens, and then you can take the barge out. Now this is also very critical because this is the time when the deck has completely been transferred out. The the barge has a lot of freedom to move up and down because the heavy weight from the top is gone now. So this is the time you have to make a quick separation. This gap should be big enough so that the barge doesn't go back because of the sea waves and go and hit against this. So this clearance has to be made as soon as possible. And that's also a very critical step where we take in a lot of ballast water. Okay, now since we have understood the float-over meeting sequences, now the second part of the presentation is what are the float-over hardware. So we discussed a few of them in the beginning. We have something called LMU. This is called a stabbing cone. Basically, it's a locator pin, and onto which there's an equivalent mating receptor cone, which this might be on the jacket leg, and that can be on the deck leg. Then we have between these two, as we said, we need a shock absorber. So the shock absorber is what you call as the LMU, the leg mating unit. So it essentially consists of two cans. There's an outer can and an inner can, and they can slide in between each other. It's like a piston. And inside this area, you have elastomer cells, the rubber cells. So what happens is when there's a dynamic load happening here in this direction, so this inner can goes in, and the energy of the load is being dissipated by having the shock cells in this location here. So it is basically like a car shock cell that you have. You have similar such device in the car as well. So that's, as we saw, was on between the legs. Now what happens between the deck and the barge? So there we have something called a DSU. It's called a deck support unit. So what happens there is you have two face plates. This one connected to the deck and this one connected to the barge. And between this you have another elastomer which also acts as a shock cell, and these are the external cans or pins that will ensure that these don't fall apart. So basically, explaining like this, this is your barge, this is your deck. In between the barge and deck, there are some legs which are having these face plates, and they are the separation point. So when you happen to do the float over, you have to make sure this separation points are the cans that we have, that is for this during the transportation. Otherwise, because when you're transporting, it's just the barge is moving like this, let's say, and there should be some restraint so that the deck doesn't fall off. So at the float over point, you have to cut those restraints, and when you make sure when your barge takes in water, it goes, the barge separates out, and the deck remains sitting on the leg baiting unit, as we explained before. So this is our drawing, computer simulation of that. So we have with the top can, these are called the capital plates. There is elastomer, and the lower one goes to the the deck through a DSF. Now, I just mentioned something called a DSF. Now, what is DSF? DSF is basically a structure which distributes the load from the decks into the barge. Just imagine, we talked about a deck which is 20,000 tons, and it is having 8 legs. So each leg is something like 2,500 tons. Now, if you have 2,500 ton point loads happening on the deck on the barge, then it will definitely puncture a hole through the barge, so which is not possible. So you have to transfer the load in the horizontal direction, and that's what is done by this truss arrangement here. So having quickly explained to you, another 5 minutes. Okay. Now quickly I take you through the computer simulation. So what we do here is we have the barge model as in panels like this. So we do a 3D diffraction model of the barge, and then we have the model. We model the deck as a rigid box. We have the critical models as ground elements, and we have physical line connections. So you can see here the modeling between the DSU and the LMUs are like this. We have we'll model them as springs. So each one has got, let's say, X springs, Y springs, and there's a vertical spring that is applicable for LMU and DSU both. Similarly, so all the modeling system, all the springs and etc. can be modeled as this. These are the springs at the LMUs. The DSU. These are the LMUs, and these are the mooring lines. The mooring lines are discussed as tension only springs. Now, how do we solve it? Now we have a typical spring mass damping equation where we have the mass matrix, which is the mass of the barge, the deck, and this is the damping coefficient. The damping coefficient is from the water. The dampener is coming from the water. This is the spring coefficient of the springs that we just talked about. These are the accelerations. So if you solve this equation, the Ft is the external force that is happening due to the waves and currents. So if this happens, then you can find out from here the x double dot, x dot, and x, which is basically nothing but this acceleration, velocity, and displacement. So displacements will give you the excursion, this will give you the velocities and accelerations, and from there you can find, because you know the various stiffnesses of each of the LMU, rubber, and the mooring lines, etc. So you can find out the corresponding forces. So whole body is basically linear, simplified into a spring mass, and a damper system, and the solution to it is very easily available in most of the structural engineering and mechanics books. Okay, so I'm in a hurry, so let me quickly take you through. I just said that the x will give you the solving for x will give you the excursion of the points on the body, and it will give you the other things will give you the acceleration and the forces. We do a time domain analysis. We do omnidirection for all weathers, and we find out all the loads. And what we do is we incrementally change the weather and find out the maximum loads that we calculate and compare against what is the permissible loads in a particular hardware. Like, for example, you calculate for all the weathers and find out let's say the line tension is 80 tons, and then you're using a 2.5-inch steel wire. So you know, okay, to 80 tons means I can go up to another 100 up to about 105 tons or something. So that means you can actually increase the weather. So this is the way we find out the limiting weather in which to do the work. Now this is the final part of the presentation, which we'll talk about how does it help determining the model. So these are the two typical jackets. This jacket is about a lifted, when you have a lifted deck installation, and this is for a float over. Now you can see for the float over, you have a big slot needed, what we call as the slot width for the barge to enter, and there's also a big cantilever on the deck leg, so that, because the first braces are here, where jacket actually physically cannot go any further. So essential difference is that in a float over jacket, you have a big cantilever and a big slot width. So based on the calculations that we have talked about and calculating the x and y forces in the jacket legs, so you can find out how these legs, what these legs will be, what loads will be there on the legs, and from there, from the x and y and z forces, you can find out what kind of design you'll need for them to take care of the jacket. So essentially, what I'm trying to say is that if you have bigger loads, then you will need bigger wall thicknesses. The jacket leg dimensions may go up. If the impact vertical loads are too high, that means you need bigger LMUs, and in that case, the jacket leg again goes up, and also the pile sizes go up. So basically, as you calculate, as the load goes up, the sizes, the dimensions of the jacket goes up, and also increase the cost of the jacket fabrication. Same happens with the deck as well. Now, quickly on the barge. Now, just imagine, we had talked about the fenders between the barge and the jacket. Now, if the impact loads, if the weather is too high, the impact loads are too high, that means you will need bigger fenders. If you need bigger fenders, that means your slot size goes up. If you need bigger slot size, your barge, you have to go to the next size of barge. Again, it goes up in the cost. So basically, in short, because I thought I was going too fast, and maybe a little bit of explanation may be necessary. So all I'm trying to say is that the load calculation is very critical, because if you calculate the load correctly, you know what kind of horizontal, vertical, and lateral loads goes into the system. You can understand when the barge goes and hits the jacket in this way, these loads are very critical, because the jacket is not strong enough in this direction rather than that direction, because there are braces here. So when this happens, you can find out, okay, do I have to make the legs bigger? Do I have to put bigger piles there? Do I have to increase the rigidity? How does it affect the cost of the jacket? And so on. So similar thing happens to the deck, because similar loads are being transmitted on the deck from the DSUs. So if you have too much impact load, it may actually damage your deck equipment, or you may have to make a completely different kind of a deck support unit, and make sure that loads are transmitted well. So in conclusion, it's very, very important to find out the loads in the design stage itself, find out the hardware that you need at the design stage itself, take a stock of what kind of barge that you need for the float over, and from these loads you can find out, actually estimate the load on the weight of the jacket that's good that you go to fabricate, or whether if economically, and every bit of dimension that goes up obviously adds to the cost of the project. So you can take a call and find out whether you really can do a float over, or you should not do a float over, depending on, sometimes, as I said, it is not possible to do any other installation operation. I mean, it's not possible to do a lift, let's say. So that's a foregone conclusion. But when there is a comparison between doing a float over or doing a lift, these cost calculations are very important to decide whether we do a float over or not. Thank you. I'm sorry I had to hurry up because I really didn't do it. Hope you have some. I will be glad to have some questions. I don't know if you have more. We can take it offline and discuss sometime during the breaks. Any questions, please? Yes, sir.
Hardware.
I'm sorry, can you repeat? I didn't get you.
Yes. What, in your experience, would be the core difference between a reversed float over and a float over in terms of hardware and the loads you expect?
Okay. If I get you right, reverse float over means you're doing a module lift.
I mean with reverse float over for decommissioning purposes. So when you want to remove the platform, you use reversed float over.
Yeah, actually, frankly, for me, I haven't done too much of a decommissioning work, but yeah, it is exactly the same way. Instead of transferring load by ballasting the barge, it's the other way around. You have to ballast out the barge and lift it up. So again, the issue is in what do you plan, whether you have the enough water, whether you have the enough, the bottom clearance for the barge to enter. And kind of go, because it is going to enter the slot with a bigger draft. So these, again, the hardware here in that case of a reverse float over, you don't need the LMUs, etc., because they're already there, except on the barge. So the cost of the reverse float over will be lower as compared to the real float over where you need more hardware.
Thank you very much.
Yes, please. That's good. The air gap during the exit, right? No, the final air gap comes from the location of the installation. It depends on the weather that is prevailing. So it comes as a part of the owner's specification or as a part of the original ITT document, which says that, depends. For example, when we did it in Gulf of Mexico, because of the weather, we had an 18-meter air gap. Because what has happened, what is done is you ensure that 100-year maximum wave will not touch your cellar deck. So that becomes the guideline. So that determines the air gap. And if when you have a very high air gap, you have to have a very high DSF, so that you have to raise the deck up so much when you do the float over. So in case of Pemex, the Gulf of Mexico, the experience that I was talking about, we had used a 12.5 meter DSF, which is possibly the highest DSF that I ever worked with.
Because in North Sea, the air gap is up to 30 meters.
Yeah. As I said, North Sea, you don't also see too many floatovers. You have in areas where you have, and there are some of these wind harvesting farms which are putting up large units using floatover. Yeah, but then in that case, when you have such a high air gap, you have to have, as I said, a very high DSF. So the transportation cost will go up because, you might need a bigger barge, or you may need jacking systems. So all these are very interrelated, and, so you'd ideally like to do a floatover with not with a very high air gap.
Sable, understand that the most critical stage is when the deck leg meets the LMU, right?
Where are you? I can't see you.
Here.
Oh,
okay.
Sorry.
Yeah.
I got blinded with the slides.
So I'll repeat. The most critical stage I understand is that when the deck leg meets the LMU, right?
Okay. Yeah, all of them are critical. Yeah, this of course is one of the critical. Yeah.
Okay. And at that time, you may encounter the lateral forces, which you can restrain by the moorings, right?
Yes, with the moorings and with the soft with the fenders within the barge and the jacket.
Basically the second order motions, like the drift forces.
Correct.
So if for the first order motions like heave, pitch, roll and all, it cannot be restrained by the moorings, right?
Absolutely.
So is there any method by which you are trying to improve these first order motion characteristics, or you just take the loads which is coming from that and take it into design?
No, I got your question. I'll answer you. See, for the first order motions, we have the main moorings. But that will give you some excursions. If you have done moorings, you see the excursions about 1.5 meters and so on. So that kind of excursions are not going to work when you do a float over and when you're trying to do a mating within 700 millimeters of motion. Okay. So of course you need to have another set of restraints, which is basically the fenders between the barge and the jacket, or soft second orders or second range of soft mooring lines, which are basically tugger lines that we use in McDermott which is connected to the jacket leg to the barge through a mooring winch. So that stops you from the second order motions and makes the body very rigid as possible, so that you can do the mating within the preferred, which is about 700 millimeters of excursion is what we can maximum allow.
Okay. Yeah. Thank you.
If you don't have any more questions, I would thank you, everybody, for being...
No, we have more.
You have more? Okay. Sure.
Thank you, Saibal, for the presentation.
Thank you. My pleasure.
My question is this time domain analysis. At what stage of the project do you start doing this? Because at the earliest stage of the projects, you don't have the frozen parameters.
Yes. Good question. In fact, the reason for making this presentation was trying to impress upon everybody that we need to do this calculation at the design stage itself. Okay, I understand that you do not have a lot of data, but engineering is all about approximating what is possible. What I mean is that, okay, you may start with a deck which in the first pass of weight estimation may weight, let's say 18,000 tons. And do the calculation. So you have to redefine your calculations every time as you go through the process of, the process of design is that famous design spiral. So as the design gets more and more matured, you'll find there are changes in weight. But suppose you had a deck which ended up 24,000 tons and you started with 18,000 tons, you have gone really bad. Because you have decided your hardware based on the initial calculations, you have decided on your barge based on the initial calculation, and when you get a 24,000 ton deck, nothing may work. None of them may work. So you have to reinvent everything. So obviously, for like any engineering solution, a right start point is critical. So that right start point can come obviously from your past experiences with similar projects. So more you work on a particular area, you have more experience, and you're likely to zero in with your start point in a better way.
Any more questions? Probably I have one for you, Saibal.
Yes, please.
Well, just I always hear that McDermott does it one way. Other competition like other companies like NPCC is likely to do differently. So, for educational purpose, can you throw some light on
I'll be glad to.
We don't want the models, but
no, it's okay. It's okay. No, see, the basic difference between the McDermott way and the remaining world, I'd say, is something what we call as the tight slot and a loose slot. So what we do in McDermott is a loose slot. Now I can say 1,000 things in favor of loose slot, but I will not be so immodest. I'll try to make my understanding of the loose slot and explain to you. See, in a loose slot, what we have, okay, let me go with tight slot. What you have in a tight slot is you have a fender between, say that this is the barge. This is a jacket leg, and this is a slot. Slot size within the barge goes in. So in case of tight slot, they use fenders here, so that this motion is restricted. What we do is we have this slot, but we use mooring lines. We use soft mooring lines, so that is holding it tight, so it doesn't allow the barge to move this way or that way. Now, one of the big advantage I personally see with the loose slot is that in case of a tight slot, after you're done with the float over, you have to remove those fenders. You cannot just leave them and go away. So that recalls for an extra offshore work. Whereas in loose slot, it is just as I said, you had connected some kind of lasso with the jacket leg, and you had them connected to the small winches on the deck. So you have to just take the lasso out, and that's it. So the post-installation removal of the so-called fenders is not there. So obviously tight slot must be having a lot of pros for the users of that. But as I said, I don't want to comment on that because we use the loose slot, and I can give you the goodness of the loose slot.
Right, thank you. Any more questions? Yes, please. We can take a couple of more.
Thank you very much, Saibal. I'm Lekha from Green Palm Marine. My question is in two parts. First one, what is the heaviest float over that McDermott has done so far?
To my knowledge, it is 22,000 tons, which I was involved. It is in Arthit. Arthit was one. The other one was also in Pletong 2. Pletong 2 was
Pletong 2, yes.
Yeah. That was 22,000 tons float over that I was involved. Historically, there might be something bigger than that, but I'm not very sure.
For Chevron?
Yeah, Chevron. That was Chevron. It was done in 2008 in the Gulf of Thailand.
Okay, is that the heaviest in the world? Or?
No. Because I think at least there was a plan to do. I think that project got shelved. It was the North Rankin deck was, I think, something like 26,000 tons, to my knowledge. So that is even bigger than whatever I have done.
Okay, with the current running projects in hand, is there any other ones planned, bigger, complicated, or is that all?
Let the oil prices go up.
Okay. The second question is, obviously the barge is class approved. We have so many class representatives here. What is the involvement of class, or they have no involvement at all? The barge is class approved. So do you need any special approval from them, or they don't?
No, not that I really know of. The role of the classification society here is because this is something what we call as a semi-submersible barge. Because we are going at one draft, and when we are doing the load transfer, we have about 1 meter freeboard kind of left. Same thing happens during when we do the load out. So you have to really, these are a different class of barge, and which doesn't go by the freeboard regulation. You understand? So that is the role of the classification society. Yes, you can suppose I do the calculation, say for McDermott. McDermott might get the calculation revalidated by a third party just to ensure that nothing goes wrong. So that is the times maybe sometime classification society or MWS may come in.
Thanks a lot. It was really informative. Thank you.
Thank you. If you have any more questions, I can take it offline during the breaks. There are a lot of things I had to hurry up and couldn't finish, explaining how the calculation works. It's standard. It's nothing out of the ordinary that I'm talking about. But if you have questions, I'll be happy to answer them during the breaks. Thank you so much.
Thank you very much, Saibal. Big round of applause for Saibal.
Thank you.
Well, actually, it took me back to something like 20 years. I did myself as a field engineer, one of the Katagas flow towers. So, thank you for reminding me all the old flow towers. I think let me invite Mr. Kim to be on stage to present the mementos to Saibal, please. All right, I think we are time. First session is over. It's time for a tea break. So we have tea, snacks outside, and we are back in half an hour, 30 minutes. We should be back. All right, thank you. So you have more time with Saibal to ask more questions. Thanks.
Era of integrated global market. Supply chain system optimization is the key to increase company competitiveness. Now, we take a big stride forward with one-stop solution based on the worldwide global network and a cutting-edge system. The global SCM innovator, CJ Logistics. CJ, a global lifestyle company, leads the lifestyle of people all over the world. Food and food service, bio and pharma, logistics and retail, and entertainment and media. CJ Group creates the culture of cosmopolitan people in 4 major areas. CJ Logistics, the key engine of CJ Group and the leader of global logistics innovation, takes the lead with our customers at all times. With countries including the US, China, and Southeast Asia. Our logistical territory further expands with its worldwide network. CJ Logistics, with its TES-based advanced logistics technology, rich know-how on supply chain operation, and IT solution, has established one-stop logistics service optimized for each customer. TES, the key competence of CJ Logistics, quickly responds to the changing logistics market to create the new logistics paradigm. State-of-the-art and future logistics technologies, such as convergence robotics and intelligence technology. Engineering that optimizes for the entire supply chain. System and solution based on IoT technology. Smart technology and consulting with expertise, presenting an optimized solution for customers in various sectors. This is the globally recognized competitiveness of CJ Logistics. CJ Logistics established a one-stop solution for the entire logistics field. Industry group-specific sales know-how and cutting-edge IT solutions, total service of contract logistics. Based on the huge-scale domestic, overseas infrastructure and directly operated system, stable services are provided. Number 1 market share and customer satisfaction in South Korea. The company realizes number 1 parcel service. From imports and exports of marine air transportation to customer clearance and storage. With diverse stevedoring equipment and facilities, CJ Logistics provides optimal marine cargo stevedoring and transportation service. Based on diverse EPC equipment and transportation know-how, CJ Logistics Project Logistics provides a stable logistics service for domestic, overseas plant, special, and break bulk cargoes. CJ Logistics always stays as a reliable global partner to customers. CJ Logistics has the whole world as a stage. CJ Logistics is broadening its market across the world with a global logistical network. Our one-stop solution will always be with customers.
We are the best, CJ.
The global SCM innovator, CJ Logistics.
Blue Water Shipping is a worldwide specialist in project freight forwarding. And with more than 40 years of experience, Blue Water is the right team for any major project transport. The job in this project, to transport a massive lower hull and heavy topside components for a drilling rig from Asia to South America. The company's Singapore office is in charge of the challenging project that involves strong teamwork with the client, external partners, and other Blue Water offices.
Out here we are not only a freight forwarder, we are a very dedicated project freight forwarder that likes to handle complicated stuff. We did the groundwork for this project approximately 2 years ago, and we did a lot of studies back and forth, not only on a commercial level but also on an engineering level, because the cargo specifications are obviously very complex, and we have to be very thorough and have to provide our client with proper solutions.
The debut of the project brings us to Batangas, Philippines. It's here where today the future oil rig's massive pontoons will be loaded. Blue Water Shipping is responsible for the complete wet towage from the yard onto the semi-submersible vessel and the delivery of the pontoons to Singapore. Carefully, the tugs maneuver the steel colossus above the deck of the Casco XRK. Once in place, the water is blasted out of the ship's 61 ballast tanks, and both pontoons rest safely on the dry floor. The ship now sets sail to Singapore to deliver its expected cargo. The first stage of the project is successfully accomplished. The 2 pontoons will now be used to create the lower hull, the massive base structure that the future oil rig will be sitting on. 4 special tugs connect their pulling lines to the lower hull. The Blue Water team keeps a watchful eye on the operation. Slowly and precisely, the giant structure is maneuvered towards the Vanguard's deck. Meter by meter, inch by inch. Everything goes as planned. It's a major success, And finally, the lower hull is perfectly floated onto the Vanguard. Shortly after the Vanguard's departure from Singapore, the project's next phase commences: the lifting and transport of the oil rig's topside components. All heavyweight champions in their class that require complex engineering to ensure a smooth and safe delivery. Carefully, the large structures are lifted onto the vessel. It's a team effort and shows once more Blue Water Shipping's veteran experience in applying tailor-made logistics to the oil and gas industry. Precisely, in record time, with 0 incidents, and to the customer's fullest satisfaction. Finally, Hercules places the derrick tower accurately on its pre-calculated position. The ship has to travel 8,800 miles through the Indian Ocean, rounding the Cape of Good Hope, and then crossing the vast Atlantic Ocean to finally reach Angra das Reis, where just now, the Dockwise Vanguard is about to complete her journey. On her way, she had to deviate away from 2 tropical storms and battle unfavorable currents. But now, she's here. It's a magic light welcoming a mighty ship. The pilot gets on board to navigate the Vanguard to her float-off position. Only an hour later, the gigantic lower hull structure floats off the deck.